All right, 304. Good afternoon, everyone, and bienvenidos. My name is Frank Kinder. I am the Water Efficiency and Sustainability Manager here at Northern Water. And we are a sponsor of this class, and we are so glad you have chosen today to learn with us. This is the third of 3 classes that we are doing with the Colorado Stormwater Center. And we're very glad to share this information with all of you. It's our chance to provide outreach and education to the community around ways that we can all work together to save water in the landscape while performing absolutely necessary stormwater management. And Jessica Thrasher is your presenter today, an expert in this topic, having presented multiple classes for you before, as well as other programming. And we are really glad that they are such a valuable resource in the region. Today's class is offered in 2 languages, as indicated by Jessica, and those will be provided to you in a recorded format a little later on. And just a quick background about who we are. Northern Water is a conservancy district located in northern Colorado, and we serve over 1 million people in 1.5 million acres along 33 cities. Some of our metrics here are for you to review. If you've been up to Rocky Mountain National Park and you've seen some of those beautiful reservoirs up there, the water in those regions is gathered from the crucial watershed, and much of which burned last year, making water management and water quality and stormwater management ever more important. Some of that water is shipped over to the eastern slope here, stored in large reservoirs known as Horsetooth and Pinewood and Carter and Boulder, and then delivered to all of these cities. And as we receive precipitation on the eastern slope, we seek to manage that so that we can get good quality and deliver that water downstream. As the supplemental water provider in the region, we have an obligation to help people understand and appreciate the scarcity of water and then what it takes to deliver it, as well as how to take care of it and to treat it with respect. And we're doing that with you today here. Our team also provides additional resources outside of training opportunities like this via consultations, irrigation audits, indoor audits, grants for transitioning landscapes. These 9 tiles represent the services we provide to the users that receive our water. We've been doing this for about 3 years now. And if you're new to Northern Water, I encourage you to go to our website at northernwater.org and take a look at what we do. You can find this information under the in the community tab at the very top of the page. And you can find examples of the grants we've funded. We're wrapping up our 3rd grant year, and we're taking applications through November 30th for our 4th grant. If you are just learning about us, we'd be happy to talk with you about the grant steps next year. And we also have future training classes after this one today. Those include the Sustainable Landscape Management with the Associated Landscape Contractors of Colorado. We've reduced the cost of applying to this to make it accessible to a lot of different folks. And it is a 4-hour class. It's a great first step to learn a variety of methods to manage water wisely in the landscape. Next slide. So this is our first year working together. We're very excited to offer these. Jessica has an extensive background in landscape management, multiple certifications, and she practices what she preaches by doing the same efforts in her own personal property. So I think you've got a good expert in today's topics. The other thing we do is work with these communities who have stormwater management to transition some of the high water use landscapes in detention basins into lower water use landscapes while retaining their existing performance. So that basin that you see there on the right, that's using Kentucky bluegrass. It's irrigated and it's taken care of through mowing and chemical treatments. It's possible that this could be transitioned into a native turf, which would still perform the same quality requirements at the end of the day with a little bit less input from natural resources. So with that, I appreciate you joining us today. I'm looking forward to this content, and I can turn it over to Jessica.
Thank you so much, Frank, and thank you all for joining us today. We're really excited to be here for our 3rd and final class of the year of the Stormwater Education Training Series. I would like to thank our 2 interpreters that we have with us today in the Spanish room, Catherine and Dea. Thank you so much for being here with us to make sure that this class is available in Spanish as well. We are very grateful for the partnership with Northern Water. We are also sponsored by CDPHE, the Colorado Department of Health and the Environment, which is enabling us to also do this series. As Frank mentioned, I'm with the Colorado Stormwater Center. And in case you're not familiar with the work that we're doing, our mission is to advance stormwater management throughout Colorado by conducting practical research and providing education and training opportunities. We have had, as I mentioned, this is the third of the series that we have done that have been the bilingual stormwater education series with Northern Water and CDPHE. All of the blue links that you will see in this training today are, all the blue lettering is links, so that when you receive this PDF of these PowerPoints, you will be able to click on them and navigate to these recordings or to whatever website it is directing you to. So you can view the two recordings via those links below if you are not able to join us before. Additionally, the Colorado Stormwater Center has two upcoming certifications. The next one is, they're both, well, one of them is next week, and that one is the Stormwater Control Measure Inspection and Maintenance Certification. And then November 8th and 9th, we have the Design and Design Review Certification, also with stormwater control measures. In addition to the trainings and certifications that we do, we also conduct a lot of research, needed stormwater research, and so that link will direct you to the research that we have ongoing right now. And finally, we do an annual symposium. We had our annual symposium this year in August, and all of those recordings are available via this link as well. We focused on green infrastructure in action. We looked at the impacts of fire on water quality, and then we looked at what is happening around the state with stormwater infrastructure or stormwater education and training. So if you're interested, I would encourage you to go and check out those resources. For today, here's what we're going to look at. We're starting with our stormwater challenges and then diving deeper into what are the stormwater control measures that we see. And then with a specialized look at the extended detention basin, which is the most common stormwater control measure here in Colorado. We'll be talking extensively about the inspection and maintenance activities associated with the extended detention basin and examples, and then finally end with additional resources. Also, as we're going through the training today, I will have question breaks, but please feel free to enter your questions into the chat or to just unmute and ask them directly. So to start with, let's discuss the stormwater challenges that we're seeing in our environment. The first one being urbanization. With urbanization, we see the removal of green space. We have, as our cities expand, we are paving over areas that were previously vegetated. And so we're getting decreased infiltration as a result of that. And because of that decreased infiltration, we're seeing increases in stormwater runoff. And this is what that looks like. I know that this slide has small lettering, but hopefully you can all see that in the top left corner here, we have natural ground cover with 10% runoff, 25% deep infiltration, and 25% shallow infiltration. As we move to a more and more urbanized area, as you can see from the bottom slide, that we have 75 to 100% impervious surface, we have 5% deep infiltration, 10% shallow infiltration, and 55% runoff. So this is an incredibly large increase in the amount of stormwater runoff we're seeing, and this is why stormwater control measures are needed to address this issue. When we have, because the reason why we need to address stormwater is one of them is because of the pollutants that it picks up. As rain hits your roof and then runs down into our downspouts and across our pavements and our driveways and our parking lots, it picks up pet waste. Fertilizer is a huge issue as people fertilize their lawns. Frank mentioned a way that we can decrease some of that need for fertilization by transitioning to native grasses. Motor oil is also picked up in stormwater, detergents, chemicals, and all of this is deposited into our waterways unless it is first cleaned by a stormwater control measure. In addition to the urbanization, we also have climate change as one of the challenges with stormwater. With our droughts, we're seeing drought as more of the norm instead of the exception. This is making this one of the ways that this impacts is in our forests, because our forests are then more dry. And when we have fires like we saw last year, it's a hotter wildfire and it lasts for a lot longer, because the trees aren't able to withstand the normal fires that they had been previously. There are a lot of impacts on water quality with fires. If you want detailed information about this, I encourage you to check out the Stormwater Symposium. But when a wildfire burns extremely hot, it makes the soils hydrophobic. They're no longer able to accept that runoff or that moisture. And so when the snow melts, that water then runs off of those soils that were in burn areas, and it picks up the sediment, it picks up the debris, and it deposits it into our rivers. This becomes a very major issue on a lot of different levels, but just at the municipal level, and Northern Water has been doing a lot of work on this, if there's a certain amount of sediment into the rivers and pollutants, it is very difficult for those water providers to remove those sediments because it creates difficulties in their system. So the city of Greeley had to actually let water flow down the Poudre River this year and not remove it because it had too much contaminants from those burn areas. So this is a substantial impact on our water. We also have flooding issues with that increase in stormwater, as I was mentioning before. This looks like nuisance flooding, which has damage to property and also creates dangerous driving conditions. So it makes also in cities, if you want to have a walkable city, then the sidewalks are flooded and you're not able to do that. In addition to nuisance flooding that makes it just more dangerous, you might have minor property damage. Catastrophic flooding refers to the complete loss of property or loss of life, like we saw in the Poudre Canyon earlier this year. And additionally, you can have channelization occur with this higher volume of water. Channel instability and erosion is an issue because as stormwater as water flows across a vegetated surface, that water infiltrates into the vegetation. When it does that, the pollutants in the water are removed. And so those pollutants are trapped in that soil profile. And as that water goes down into the groundwater, it is cleaner. When you have channelization and water cuts a path through that vegetation, then those contaminants are released into the water once again. And then you have the additional component of sediment also being added to the water. When we have the fertilizer and the other contaminants reach our reservoirs and bodies of water, we have the potential for algal blooms, which cause hazards to human, pet, and aquatic health. And finally, along with the stormwater challenges, as we have these climatic changes, if we have increases in drought, increases of flooding, those challenges are impacting our vulnerable populations the most. So one of the challenges that we're seeing right now is around equity. And as we make those adjustments to our stormwater infrastructure moving forward, we need to ensure that the vulnerable populations, especially in low-income areas, are being brought to the conversation so that we can have sustainable infrastructure moving forward. Okay, now I'm going to start talking about the different types of stormwater control measures. Extended detention basins are only part of one of the different types. So we'll go into what those different types are and then focus in on extended detention basins. The Mile High Flood District, which was previously the urban storm drainage, they created this 4-step process for stormwater management. Step 1 is to reduce runoff, which can be achieved by LID, which is low impact development, or MDCIA, which is to minimize directly connected impervious area. Directly connected impervious area is when you have your roof to your aluminum downspout or steel downspout, to your concrete sidewalk or driveway, to your concrete curb and gutter system, to your concrete or metal piping. So that is directly connected impervious area where nothing is able to infiltrate. So by reducing the directly connected impervious area, you're allowing more opportunities for that water to infiltrate. So that's step 1. Step 2 is to treat and slowly release the water quality capture volume, or WQCV. And then number 3 is to control the source controls. So if you're not able to, fertilizers is one of these examples where it's very hard to remove fertilizers once they're causing that algae growth in your bodies of water. And so sometimes the best thing to do is to do education with homeowners to allow them to stop using so much fertilizer, because it's hard to remove once it's in the water. We're not going to talk about step 4, which is stabilizing the stream channel, but that is another step for stormwater management. I know this is very small lettering, but you will receive this slide later to be able to look at it in greater detail. But stormwater control measure classification is below, and I just want to read this to you. The permanent water quality stormwater control measure is a facility that is designed to reduce stormwater runoff, peak flow, and or pollutants before they discharge into receiving water. So that is how that is defined. There are 3 different classifications that we talk about with stormwater control measures. The first is sedimentation. Extended detention basins are under this classification. Also are constructed wetlands and wet ponds. The next classification is the filtration stormwater control measures, and those include rain gardens, sand filters, and permeable pavement. And the final classification is volume reduction, which includes grass swales and grass buffers, or green roofs. Proprietary systems are underground systems, and they're kind of their own special classification. Here are some examples of what sedimentation stormwater control measures look like. We'll be talking a lot today about extended detention basins, but here is a picture of constructed wetlands. Constructed wetlands are a stormwater control measure that are artificially created. So we're not talking about naturally occurring wetlands here. Those cannot or should not be used for stormwater management. That's a very bad idea to use them for that. But these constructed wetlands, also you cannot use mitigation wetlands as stormwater control measures for the same reasons. So constructed wetlands are a specific type of stormwater control measure, and they are used for that purpose, but they have the additional benefits of providing a lot of the same benefits as a natural wetland. And then similar to constructed wetlands, wet ponds and retention ponds are also a sedimentation SCM example. Thank you, Javier, for telling me the Spanish translation stopped. To our 2 translators, if you could please just make sure that everything is working okay, Catherine. Thank you. Javier, please let me know if it does not start back up. The next type of classification is the filtration stormwater control measures. And this includes a rain garden. What I have pictured here on the far left is a very large rain garden that can be seen at the malls in Fort Collins. Next is sand filters, and then permeable pavement is another type of filtration SCM. And so the filtration SCMs, they are pooling water on top of them and then making sure that the water goes down through that filter media in order for the water to be cleaned. Next is volume reduction stormwater control measures. This is an example of a grass swale, a grass buffer, and green roofs. And so they're trying to allow more opportunities for infiltration so that water can soak in, reducing the directly connected impervious area. That's part of the goal of volume reduction stormwater control measures. And so you can see a couple of examples there. And lastly, proprietary stormwater control measures are almost exclusively underground, with the exception of the tree box filter, which is it's concrete and that part goes underground, but you can see the tree on top of it, which is obviously above ground. The other very common type of proprietary device is called storm scepter, and it is located there in that picture on the right. So stormwater control measures, stormwater control measures are required by the Clean Water Act, especially municipal separate sewer systems or MS4 permits. When those are issued, they're regulated by the Colorado Department of Public Health and the Environment, or CDPHE. As a part of this permit, you are required to maintain the stormwater control measures to ensure long-term sustainability or operability of them. And there are audits conducted by the CDPHE or EPA to ensure that they are being maintained and that they are operating correctly. Why is maintenance needed? Maintenance is needed on stormwater control measures because they are designed to capture and slowly release stormwater. And when you have them because they're designed to capture that water and slowly release it, those particulates are dropping out of the water. That's their function. And when that happens, if you don't clean them out regularly, then they're contributing to more pollution downstream. If you have a clogged outlet structure, which we'll be talking about a lot in a lot of detail later here, they can result in standing water because the water cannot get out through the outlet, or water bypassing the stormwater control measure and it's being released inappropriately. That water is not being treated, and so it's being a source of pollution. As I was saying here, they're designed to remove trash and debris and pollutants from the water. And if they are not treated, then they add more pollutants than they remove. And that is not the goal of stormwater control measures. And as you can see here, this one has not been maintained correctly and is just the water that came in is relatively clean, but the water that goes out is dirtier than it was when it entered the stormwater control measure. And it's not performing as it should because it's clogged. And especially if these stormwater control measures are in HOA areas or areas that are to the benefit of the community, then this becomes unsightly and unattractive, and it's not something that people want to be around. Stormwater control measures are not being maintained usually because it's believed to be too expensive. The owners don't know that they're responsible for the maintenance, or they don't know that they actually have this stormwater control measure on their property. They don't know that it's theirs and that they are responsible for that maintenance and inspection. Potentially it's because the inspections aren't frequent enough, even if the owners do know that they own it and that they are required to maintain it. The inspections just are happening at irregular intervals and they don't know how to or what needs to be maintained because of that. There are some older designs that made maintenance very difficult. And so in those cases, the maintenance isn't being done because it's just very expensive to be able to go in there and maintain it. And then finally, the maintenance personnel are not sure how to perform the maintenance or what the extended detention basin needs to be performed correctly. And so that's why they're not being maintained at that level. There are two different types of maintenance. One is routine or proactive maintenance, or non-routine or reactive maintenance. The routine maintenance is the result of frequent inspections. You don't need specialized maintenance personnel or equipment. Some cases, the SCM or the stormwater control measure, you might just need a shovel to clean out the inlet or the outlet. But in some cases, you might, if it's a very large stormwater control measure, you might need more different type of equipment like a skid steer to clean that out. But you don't need specialized expertise hired to be able to come in and maintain them. And finally, routine maintenance is the lowest cost. Non-routine maintenance is the most expensive. In this picture here, this was at an HOA, and the HOA was not aware that they needed to maintain this property, or it was too expensive to maintain originally, or they thought it was too expensive to maintain, which led to them not maintaining it at all. And so then this is actually a trickle channel, and I'll show you an example of that here in a few minutes. But this trickle channel collapsed, and it caused them $25,000 to fix it. And this type of situation, when it starts to look like this, you have complaints, there is flooding issues potentially, it requires major rehabilitation. You have to hire your engineering and construction expertise in order to be able to bring in that concrete and have it regraded. So it's very expensive, and you don't want to get to this point. Here are the inspection and maintenance roles and responsibilities. You start with your regulator, which is CDPHE, and then you go down to whoever receives the MS4 permit, which could be your city or county. The arrows that are dashed are for who reports. Those are who reports back. And the solid arrow is who does the enforcement. So then whoever the MS4 permit holder is, then they are the ones who regulate the owner of the stormwater control measure. Generally, the stormwater control measure is not the city or county, like usually. Usually there are different owners, which could be private businesses or HOAs, and then in some cases the city or county does own them, but they prefer for there to be other owners. The owner then needs to be reaching out and speaking with the inspection company, which could be the city or county, or it could be the private contractors, and the maintenance personnel, which again could be the city or county personnel or private contractors. Ideally, the inspection company and maintenance company will be speaking to each other, but if they are not, then it's the owner's responsibility to ensure that conversation is happening and that the maintenance is being done correctly. For the owner of the SCM, they need to be budgeting for the proper inspection and maintenance. They definitely need to keep all maintenance, the documentation of the inspection and maintenance on site, and then maintain written maintenance plan as well, because the MS4 permit holder, when they do their audits, that is what they will be checking for. The inspector, when they go out and inspect, they need to be looking at what is currently happening, what are the current maintenance needs, but also looking to the future to determine what will need to be maintained very quickly. The inspector may not know, hopefully they know when the maintenance personnel will be coming out there, but they may not be close together. So for example, if the inspector comes out in the springtime, they might notice that there's a clogging of the outlet and that there are some sediment that needs to be removed. But if the maintenance personnel isn't coming out until fall, then they'll need to also put on the report that leaves will need to be removed, and these additional sediments would have been accumulated by that time. So the inspectors really need to be able to look at what's currently happening and then look forward to see if there's any other issues that could be coming down the road until those maintenance personnel are able to maintain the stormwater control measure appropriately. Additionally, identifying any design problems. These could be that when it was designed, for example, the forebay or near the inlet doesn't allow the maintenance personnel to get in there with the appropriate equipment that they need. So if the inspector notices this and talks to the owner about it and says, it would be cheaper for you to do a small redesign of this one area so that it's cheaper in the long run for maintenance, the owner might be able to make that decision and take that under advisement. And that could be something that really helps the long-term sustainability of that stormwater control measure. The inspector also needs to ensure that the stormwater control measures are constructed properly and identify any issues that would cause this stormwater control measure to fail. Do all of your inspections in writing and in photographs, and then clearly state the maintenance needs and non-compliance notices to the owner, and identify the proper personnel, equipment, and expertise needed to maintain it. So if the inspector just says, remove sediment, that is not helpful for the maintenance personnel. The maintenance personnel doesn't know if they need to bring a wheelbarrow or a skid steer. So by being very clear in the inspector reports, it really helps to make sure that the maintenance personnel has what they need to get the job done. The maintenance personnel need to be sure to follow the stormwater control measure maintenance plans that have been sent to them by the owner. They need to also look at even if it's not on this list that the inspector gave them of what maintenance needs to be done, they need to see if there's anything else that needs to be done while they're there. And then also look at potential design modifications that would make their job easier or less expensive for the owner. Landscape contractors also play a great role in this. They are on site and potentially see the stormwater control measures multiple times while they're there during the summer months, and potentially, in the fall months or winter months as well. So when you're out there, look for the stormwater control measures at the sites that you're visiting. You can be a point of education for the owners and let them know that they are responsible for the inspection and maintenance of their stormwater control measure. You could potentially even offer services to inspect and maintain these and serve as those inspectors and maintenance personnel for these privately owned stormwater control measures as well. We have our certification course for inspecting and maintaining, and that is one way that you could add to the services that you are offering to your clients. Wanted to offer people an opportunity to ask questions here before we move on to more in-depth discussion on the extended detention basins. And again, you can put those questions in the chat, or you can just unmute and ask them. Okay, let's dive into extended detention basins. As you can see pictured here, this is just a review of the different kinds of sedimentation SCMs, which extended detention basin is one of them. Here is the sedimentation process. So water comes in to the extended detention basin, and the process is such that water is held for a period of time so that the particulates and pollutants can settle out. So water comes in, as you see here in this box, the water level goes down because the outlet is controlling the speed at which water exits the extended detention basin. And then the particulates that you see on the bottom are left there in the extended detention basin. So that is the process of sedimentation. Earlier, I mentioned the water quality capture volume. It's also called the WQCV. And the EPA defines this as the amount of stormwater runoff from any given storm that should be captured and treated in order to remove a majority of the stormwater pollutants on an average annual basis. So what that means in reality is that the water quality capture volume is designed to treat storms runoff 80% of the time. So the water quality capture volume is looking at the area surrounding the extended detention basin, and then it's a calculation used to determine how big the extended detention basin is by how much water will be flowing to that stormwater control measure. And then the way that that extended detention basin is designed is really only to hold 80% of storms. The reason why it's only 80% is because it was found that that is the most economic way to create the EDB, the extended detention basin, because a higher percentage doesn't really add that much value as far as the water quality capture volume, the removal of pollutants, but it adds a substantial cost. So when people were evaluating, how big do we need to make these, the civil engineers were working on this, that is what was agreed upon, was that 80% of the water quality capture volume, of the storms rather. Extended detention basins have a 40-hour drain time approximately, if they are only being used for the water quality capture volume, or that 80% of storms. These systems, the EDBs, can also be used for flood control. So in some cases, you will see the water quality capture volume is a lower segment of the basin, but then they are larger or they're deeper because these are designed for flood flood control as well. And so in the cases where they are deeper than they would be originally and are for flood control, those need to drain in less than 72 hours. So by Colorado water law, water cannot remain in one of the stormwater control measures for longer than 72 hours. But that would be why you would just see them, just know that sometimes you have just the water quality capture volume, and that's the size of the stormwater control measure. And sometimes it's also for flood control. Here are the different components of the EDB. We have the inlet where water comes in. We have the forebay, the trickle channel, potentially a micro pool, and the outlet. Inlets, here's a couple of different examples of what inlets can look like. There really isn't one type of inlet that you will see. It really depends, and it varies from EDB to EDB and how big the area is being treated, what sorts of pollutants are in the surrounding area, what issues do they have potentially with trash and debris, how much sediment is being accumulated. And so it's really dependent on the site. So EDBs are difficult you can't just say, here's the EDB, here's what all inlets will look like, because that's just not the case. So here's a couple of different examples of what some inlets look like. They might have a forebay with them, which we'll be talking about next. The second picture is looking at an inlet as well that doesn't have a forebay, but it has a trickle channel next to it. The third picture has two inlets side by side. And then this last inlet is a very small inlet going to a small extended detention basin with no trickle channel. The maintenance activities that you need to be doing for your inlets is removing any large woody vegetation. As you can see here in the far picture on the left, this large woody vegetation is undermining the concrete structure of the inlet. And this large woody vegetation is what causes inlets to fail because they get underneath, those roots get underneath the concrete and then it cracks. Then the whole thing needs to be re-poured. You'll need to get that expertise out there with the engineers and the construction equipment. So that would be reactive maintenance of having to redesign your inlet. So you need to remove any of that large woody vegetation that you're seeing. You want to remove it as early as possible. Don't wait till it becomes a tree in order to remove it. Cut it when it is small. You need to remove any of the trash that's been accumulating in your inlet or around your inlet. And like I mentioned before, the EDBs are supposed to collect trash because they are removing those contaminants from the water before the cleaner water exits into the storm drain. So trash will get into them, and that means that they're working correctly. But as a part of your maintenance, you need to remove that trash. Here on the last photo on the right, you can see that sediment has been accumulating. This is another type of inlet. It's basically just a curb cut into this extended detention basin from a parking lot. And because the sediment has been building up in this area and hasn't been maintained for long enough, the water can no longer get in because grass has grown across that inlet. And so water can't get into the extended detention basin. And when you're checking your inlets, that is the main function of the inlet, is to allow water in. So you need to do what needs to be done in order to ensure that water can enter into the facility. Additionally, at your inlet, you need to make sure there is erosion protection. So in this far picture, there is that small little arrow that says inlet, which you can't really hardly even see because erosion protection was not put in place. Erosion protection can look like a lot of different things, but what it needs to do is slow the water down. When you have water coming into one of these inlets, as you can see here, that is a large volume of water that could potentially be flowing fast. So when you have a large amount of water flowing fast, then you're going to get some erosion happening. So you can put riprap down, you can have some other measures that we'll be talking about, but if you're not slowing down that water or protecting the ground where that water is coming in, then that water will churn up sediment and eat away at the ground below it, creating what looks like in that picture. So this eroded sediment has completely covered the trickle channel. This is a major source of pollution for our water. And we are now, since all of this sediment is going into the extended detention basin, it's no longer able to perform at that level of the water quality capture volume because all of that sediment is going down to the bottom of that extended detention basin. So it's filling it up. So less water is able to stay in that basin because there's less available space for it to be contained inside. Erosion can also look like the picture on the right, where again, there was no erosion protection, it caused undercutting, and eventually it caused the failure of the trickle channel of this inlet. Here are some examples of a clogged inlet. One of our coworkers was checking out this inlet and saw that it was clogged upstream. Didn't know why, this upstream inlet was clogged, and so went downstream and saw the picture on the right. So what had happened here is this had not been maintained for so long that it had trash and debris and sediment and grass growing in there. And so what happened was the colleague told the owner of this extended detention basin, hey, all of this needs to be maintained, all of this needs to be removed. Flooding is occurring upstream, and this is causing issues for water quality. So what they did was they removed all of the trash and debris and sediment. They put in these two tiny corrugated pipes. I don't know if you can see my cursor here. These two tiny corrugated pipes right here, and then put all of the trash back in the inlet, which is not what you need to do. This was not solving the problem at all. The reason why that inlet was constructed to be that size is because of the engineering behind it for that specific size of extended detention basin. So by just putting those two small corrugated pipes in there and allowing a tiny bit of flow to come in, you are going to have upstream issues with that. So what needed to happen was they need to remove all of this trash and sediment and debris in corrugated pipes and allow water to run freely through the entirety of this concrete pipe. Next is the forebay. And the function of the forebay is to capture large sediment and debris and facilitate maintenance. Sometimes you see energy dissipation inside the forebay as an additional component. The forebay, if it does not make it easier to maintain the extended detention basin, it is not a good forebay. And that's it, because you're supposed to be able to collect all of that trash in a location where it's easy to remove it. And if it's not, then the forebay might as well not even be there. So one of the examples here on the left, we've seen a couple times. So this forebay is slowing that water down a little bit and having this area where the trash can accumulate. When I'm just looking at this picture alone, this looks like a good forebay. You can see that a little bit of sediment has been accumulated in that forebay there. But without knowing how the maintenance personnel would get to the forebay, I can't say for sure if that's a really great forebay or not. The next example has a very large forebay. You can see this wall going all the way across the front of that forebay. It looks like there is a substantial amount of water that comes into this extended detention basin. And there's a small little hole. You can see my cursor right about here where the water is exiting. Now this forebay looks really good, but from this picture, there is no way for maintenance to get into this forebay with the equipment that they would need to clean it. So it would be easiest if they had a maintenance road that went to this forebay, and then they were able to bring in a skid steer to remove all of the trash and debris that was getting in there. But they would not have to because there is that large wall up here. There's no maintenance road. They have to basically get a wheelbarrow and a shovel and go all the way around the structure to be able to get into this forebay and then lift it over this wall. So this is not a good forebay, even though it looks clean and nice, because it is not making maintenance easier. The next picture of this forebay, these are baffle blocks. They look kind of like dominoes. And over here, we saw in the first picture as well on the left, this is a weir. So the baffle blocks and the weir are both slowing down the water, and the baffle blocks are providing energy dissipation as well. So you can see the sediment dropping out in that forebay, which is exactly what it needs to do. And then in the final picture, there's another example of a forebay. You can see that grass is growing in there because of the sediment that's accumulated. It's not that big of a deal if there is grass in your forebay, like in this sort of example. You just know that you need to clean it out. You know, it becomes a bigger issue when there's not regular maintenance happening. So again, if you have those pollutants, you should have pollutants or trash or debris or sediment in your forebay. That means it's working correctly. If you go out there and you never see anything in your forebay, then that's called a self-cleaning forebay, and that was not constructed properly. There's not enough hold time for that water in that forebay to allow those pollutants or trash to accumulate, and so that's not functioning correctly. Here's another example of some different types of forebays. These should start looking familiar because in the inlet, we did very similar things. You need to remove the sediment and the trash and debris, make sure there's no large woody vegetation in the forebay or right next to the forebay. And forebays typically require maintenance once a year. So in the example on the left, this EDB had a forebay. What happened was they were repaving a street that ran into this forebay, or into this EDB. So then there was a large storm, and so a lot of that material was washed into the EDB, and because they had a forebay, it was captured and collected there. If they had not had a forebay, all of that gravel would have been spread along the very bottom of the EDB, which would have made it very difficult to remove it, dangerous to be mowing in there, and in general, a really big hassle to maintain. So by including a forebay, you are making it easier to maintain your extended detention basin overall. The next example, here in the back, you can see that they have a type of erosion control because it's slowing down. It's kind of like a very large baffle. It's slowing down that water as it enters and then entering into this forebay. And here is that weir once again, or there's the place where the water exits. And so all of this sediment, all the vegetation that's in there needs to be removed. And you can probably guess that this forebay has not been maintained annually. One of the questions that we get is, how do you know when it's time to maintain your forebay? When do you go and clean it out? And again, usually annually, but if you see ice buildup in your forebay, then it's usually a sign of sediment accumulation and that you need to clean it out because it's ponding in there, and that's because of the accumulated sediment. Another way that you can tell that you need to clean out your forebay is if there is sediment on the outside of your forebay wall, like here, and that means that the water is pushing the sediment up and out, and that is an indication that you need to clean it. Here's an example of a very large forebay. This forebay isn't for an extended detention basin. It's actually for a wetland area, a constructed wetland in Fort Collins. And this forebay is connected to a very large area, and so it receives a substantial amount of stormwater. And the reason why they have this very large forebay is because they're trying to protect their constructed wetland and not have to go in there and clean that out. So they have this forebay, and it's very easy to get into. They can get the equipment that they need in there. Obviously, they need larger equipment to be able to remove all of the sediment from this particular forebay. And then right outside the picture, which is over here, they have a dump trailer, a very trash receptacle that's very large. And they dump all of the sediment in there. It is then dewatered in that trash receptacle, and then it is hauled off to the dump. After they do this, they maintain this forebay about 3 times a year just because of the amount of sediment they receive. So this is another example of making sure that you have the right size forebay for what you need and that you can get the equipment in there. Here's another example of a forebay in Denver. So this is a forebay actually for a rain garden, but when they were creating this rain garden, which is another type of stormwater control measure, they wanted to make sure that their forebay was easy to maintain. So they created this drive-through forebay. This functions for the majority of the month as an additional parking spot. Right here, additional parking spaces for this park. But once a month, they have street sweeping, and they come in with a street sweeper and they sweep this forebay, which is the entry. You can see here are the holes on the other side of it. And then here's a closer example of what it looks like before the street sweeper and then after the street sweeper. So they just made the maintenance as a part of their regular routine. It doesn't take any additional time since the street sweepers are already coming monthly. And so this forebay gets cleaned 12 times a year, which works great for this rain garden. But this is just an example of how you're keeping maintenance in mind when you're creating a forebay, and you're making it easy to maintain it and cheap to maintain it. Here's another example of a forebay that was connected to a retention pond. And this forebay was not working well. Over here, this is the forebay, but it's a wet forebay, which you can have a water in a forebay. It doesn't have to be dry. So it just really depends on what was constructed for that site. The forebay was trying to remove the trash and debris because once it gets into the retention pond, it's very difficult to get out. They have to get in a boat, and it's very time consuming to go out and scoop all of the trash out of the retention pond. So it is very, and this is an aqua golf facility where the people hit golf balls into this retention pond that then disintegrate. But it was definitely in their best interest to make sure their forebay was capturing this debris. They had tried to put this fence up around it, but it failed, as you can see. So they're having a lot of issues with it. So they decided to concrete this driveway area and then put up this fence next to it. They did all of these modifications to facilitate maintenance, to make it easier to trap the trash and debris and not have to get into that boat and start collecting it with a net like they had been before. So what happened was there was a pothole higher up in the watershed, and that sent a ton of sediment into this forebay. And because they had made these modifications, they were able to stop the majority of the sediment from getting into their retention pond, and it saved them a lot of time and money. It was much easier to remove the sediment after the modification. They just came in with the vac truck and sucked up all of that sediment. And they also had a shovel there to facilitate some of that. But this change really helped them in the long run, and it continues to be a functioning facility. If all of that had gone into the retention pond, they would have had to dredge out the bottom of that retention pond to remove all of that sediment. So that would have been extremely expensive. So in some cases, it is much cheaper to make those modifications to your forebay to ensure that the rest of your facility will be cleaner. Next, we have the trickle channel, and the trickle channel is conveying small flows of water through the facility to facilitate maintenance. So if you don't have a trickle channel, then the water just goes on the very bottom of the EDB, and it creates kind of a soggy area that makes it very difficult to mow, and it's generally kind of swampy at the very bottom of your EDB. So the whole idea of the trickle channel is just to have this area for when you have those very minor storm events, that it just takes water quickly from the inlet to the outlet without getting the rest of the EDB saturated. Again, you need to remove the sediment and debris and large woody vegetation from the trickle channel. Check for erosion. There are a couple of different types of trickle channels. So on the far left picture, this is a curbed trickle channel. As you can see here, why that would be called that. These can be a little bit tricky because if you don't have the right level of your vegetation or your soil to the very top of that curb, you can have a little bit of a step down from the bottom of your vegetation or your soil profile to the curb. So what happens then is all of the water runs along the side of the trickle channel instead of running into the trickle channel, which undermines the whole facility. And then you have to come in and regrade the EDB to make sure that that soil is at the very top of that trickle channel curbing. The other type you'll see in the example next, but you can see here in the middle picture that this trickle channel was not maintained. They did not remove that vegetation. And so they can't even see, you're not able to see even where that goes. In this third picture, they need to do a lot of cutting. That vegetation has overtopped the trickle channel. And so all of that needs to be cut back so that water can move quickly from the inlet to the outlet once again. Here's a picture of before a trickle channel was maintained. You have a lot of sediment and that vegetation kind of coming together. You can see why you would need to do regular maintenance or else the trickle channels could disappear altogether. And then on the right, you have the maintained trickle channel, and this is a V-type trickle channel, so there's no curbing on this one, it's just a V, and so water can flow more easily into these. These tend to just work easier, and you don't have to worry about water necessarily flowing on the side of the trickle channel instead of into it. But you still need to make sure that the soil level is up to the correct height, even in the V trickle channels. Here's another example of a trickle channel that they waited too long to maintain. And here as well, in this particular instance, they had to go back to the designs to find out where the trickle channel was and then cut back all of that vegetation so that they could find it once again. You might see some trickle channels that have riprap. That's what this large rock is called. These are very difficult to maintain. So if you're imagining that you have the water coming in from your inlet and it's flowing through this trickle channel, and then it has all of that sediment in it, the only way to get the sediment out is to remove all of the rock, clean all of the rock, and then clean out the trickle channel and then put the rock back. So same with forebays, when you're trying to make maintenance easier, this is actually just making it more difficult to maintain your extended detention basin. And so this is not a good example of a trickle channel, and concrete trickle channels are much easier. In this case, they waited too long, like in the pictures that we had before. They waited too long to maintain their trickle channel, so the vegetation overtopped it and they didn't know where it was located. So they decided, this particular owner, instead of finding the drawings and uncovering the trickle channel, they just made a new trickle channel. And so that's from this picture on the right. They just dug this new trickle channel from the inlet to the outlet. And what I was saying earlier about when you have channelization with vegetation, that all of those pollutants go back into the water, that you have more sediment going back into the water, you're decreasing the water quality. And this is not what you need to do if you cannot find your trickle channel. So this caused this owner to fail their inspection. This is really harming our watershed instead of helping it, which is what the stormwater control measures are meant to do. And they had to hire out an expert to come out here and fill in the trickle channel they just made, and then create the new one. And they had 30 days or 30 or 60 days to do that because of how much they were polluting the watershed by doing that alteration. The next component we have is the micropool. Not all extended detention basins will have a micropool, but it's important to know what they are and the reason why we have them. It is a permanent pool of water whose function is to minimize clogging of the outlet structure. So this is not a small amount of water that this is holding. It's about 2 to 2.5 feet deep, and it's always there. Here is what the side view of the micropool. So this picture here, Frank, can you see my cursor?
No, we can't.
Okay, well, that's not very helpful. Okay, so this line right here is the permanent water quality, or the permanent level.
Now we can.
Thank you.
Pictures.
Thank you. This is the permanent level of water that is always in the micropool. And so this is where that is just what's always there. You have this sloped area, and that is what you will see. And then we'll go into these different components in a minute, but just so you know, this is the level that will always be there in a micropool. The initial surcharge volume is the area of your basin that will fill up first. And when you have that first initial storm surge, that's the area that will get water first, and then it will drain last. So you don't want there to be a large area that of vegetation or in your EDB that is holding that water. You want to make the initial surcharge volume, that area that will fill up first and drain last, as small as possible. Because if you have pooling or standing water on vegetation, what happens is what you see here is that vegetation dies. So you need to consider what is the material underneath your initial surcharge volume. And it's better if you have it be concrete versus vegetation, because then the vegetation just gets killed. So here's what that looks like. So right here, we have what I was telling you before. This is the micropool. This is the amount of water that's always there. The initial surcharge volume, this has been designed so that the initial surcharge volume sits on top of the micropool. So by water sitting on top of water doesn't cause any damage. So this is a really great place to put your initial surcharge volume. That's just built into the design, and that can help keep your extended detention basin looking good and functioning how it should by incorporating that. You need to maintain your micropool. It doesn't need to be annually. From here, they have a vac truck or a truck with a vacuum coming to suck up all of the accumulated sediment that has been into this micropool. But if you have a functioning forebay and a trickle channel that you're maintaining annually, you don't have to maintain your micropool as often. But you still need to be looking to remove any sediment or trash or debris. You can perform mosquito and algae control, and then also do a structural inspection, making sure that you don't have that woody vegetation undermining your concrete structures. And one of the questions that we get a lot and why people don't like micropools is because they think the perception from the community is that they are mosquito breeding areas. And they're not, because mosquitoes like to lay their eggs on a very shallow amount of water. And since these are 2 to 2.5 feet deep, you do not have typically mosquito issues in micropools. The reason why you might have a mosquito issue in a micropool is if you have, like this picture here, if you have a ton of accumulated sediment. And so what ends up happening is there's actually just a small amount of water at the very top of that sediment, then you will have issues with mosquitoes because it's a small pool of water or a shallow pool of water. But when it's functioning properly and it's a deep pool of water, you should not have any issues with mosquitoes. Now, algae is common in micropools. So I was mentioning before that algae develops in our rivers and lakes when contaminants go in there. When algae dies, it absorbs oxygen, and so then it removes the oxygen from the water, which kills fish. So algae is not good for aquatic ecosystems. Algae is good for micropools because we're not trying to create an ecosystem. We're trying to remove pollutants from the water. So the algae actually absorbs more pollutants than when you don't have algae there or present in a micropool. So it's actually a really great function to have algae in your micropool, but it smells bad and people don't like the way it looks. So that is just for your information, kind of what typically can happen with a micropool. Like I was mentioning, you can conduct this maintenance of a micropool every several years if you have maintained the trickle channel and you have been maintaining the forebay. You, as an additional component, since this is 2.5 or 2 to 2.5 feet of water, you need to make sure that you have a way out of the water. So here, it's a little bit hard to see, but there are steps here so that if an animal falls into the micropool, they can get out. And then, of course, a worst case scenario, if an animal for a child or if a person falls in, they're able to get out as well. If you have a micropool or an extended detention basin with a micropool right next to like an HOA or a playing area, the better idea might be to put a safety grate over it. And that's pictured in the right here. Here, this is the safety grate so that no one can fall into the micropool. Okay, here's a picture of a very large micropool. So they have put a fence around their micropool and you can see the guy standing in there. So it's very large, but this is the way they have performed this protection so that people don't fall into that micropool. And they do have a ladder right here so that in case for some reason someone does fall in, they're able to get out. And then the picture on the right is just showing you the scale of how large the micropool is. Here's the inlet over here, the trickle channel, and then the micropool and the outlet. The outlet structure is the component that controls how quickly water leaves the extended detention basin. So the outlet structure is providing that pollutant removal and cleaning the water by slowly releasing the treated water. This is the component that, again, provides the primary pollutant removal. Some people think that the forebay does that because it's capturing that big debris, but that's not the part that's ensuring that the water quality component is being done, and that's by the outlet structure. There are 3 different components to the outlet structure. There is the trash rack, which can be a well screen or an aluminum bar grate, depending on the size of the orifice plate, which is the middle picture here. This is the picture of the orifice plate right here. And then you have your safety grate. So just like there was a safety grate over the micropool, you also need a safety grate over the top of the outlet structure. The trash rack keeps the orifice plate from clogging. And then the orifice plate provides the pollutant removal. So the trash rack goes right in front of the orifice plate. The trash rack holes are smaller than the orifice plate holes because anything that gets through the trash rack needs to be able to pass through the orifice plate without clogging it. So there are smaller holes for the trash rack, but more of them. So it's not inhibiting the flow of water. It's just keeping that orifice plate clear and allowing water to flow freely through it. When you are doing maintenance or your inspection on your orifice plate, you want to make sure that the orifice plate is firmly connected to the surrounding structure. You don't want to ever remove it unless you're replacing it, of course, but otherwise never remove it. Check for any gaps or modifications in it. You want to make sure that it's still functioning the way it should. If there are any gaps, if it's been removed or sometimes I'll show you what people do to the orifice plate sometimes here in the next slide. But if you see that it's, askew or disconnected in any way, that means that water is able to flow through the orifice plate more quickly than it should. So the holding time will be less than 40 hours, which is what it's supposed to be, to ensure that that sedimentation process can take place. If that sedimentation process isn't taking place, then the pollutants have not had enough time to go down to the bottom, or to fall out of the bottom of the water to the bottom of the EDB, and they're just flowing into our storm drain without being cleaned at all. So it's very important that the orifice plate is functioning how it should. If you have a clogged hole, something needs to be done called orifice restoration. And that's basically just sticking a stick in the hole to unplug it. So it's nothing major, you know, it sounds a lot more fancy than it actually is, but just make sure that that orifice hole is no longer clogged, because then again, it's not providing the right holding time. If you have a clogged orifice hole, then the holding time is longer than 40 hours. It's longer than it should be. And then it's also not performing how it should. You're starting to get ponding for extended periods of time. If it's over 72 hours, then you are not in compliance with water law, and you're also having, you're probably killing vegetation as well. Here are some examples. So people ask, you know, how can we tell if the orifice plate has been modified? How do we know if the holes are the size they should be? So just kind of think about the people who are going out and modifying these aren't like removing the orifice plate carefully and going into their machine lab and making the holes slightly larger. I mean, that's just not what's happening. They're taking a zip bit and then they're hacking away at the orifice plate so that it looks like your left-hand picture, where they're just trying to make the hole larger, but it's not pretty at all. And so any modification most likely to the orifice plate will be very easy to spot, because it'll most likely look something like this. The reason why people do this is because they see water that's ponded. You know, they see water sitting in this extended detention basin and they think, oh no, something's wrong with it. I don't want water sitting there. And they try to make the water go through it quicker. So that's why they hack away at the orifice plate. And then water does exit quicker, which of course, as I've already said, is really bad. And that is not how this should function at all. And this is an inspection failure. This needs to be fixed immediately because it's causing more pollutants to be put into our water bodies, and it's not providing what it's supposed to be doing. The next picture is the orifice plate was either not installed correctly or it was detached on purpose. So this is when you go and you look at the orifice plate and you're checking to see if it's on there. That is not on there. So that is allowing water to flow freely through it as well. Here are the trash racks that I was telling you about. So the well screen has smaller holes, and you would need to use this if the orifice plate holes are less than 1 1/4 inch in diameter. The aluminum bar grate can be used if the orifice plate holes are larger than that. So in some cases, when you have, if you go out to a site and you see there's a well screen and that there's ponding issues and the water isn't able to move quickly enough through the outlet structure, you might talk to the owner about upgrading to a larger hole size orifice plate so that you can get a aluminum bar grate to allow, with those larger holes, you know, you'll be able to allow more to go through there, less will clog up that trash rack, and then you won't potentially have these ponding issues on your EDB site. For your trash rack maintenance, whether it's an aluminum, whether it's the stainless steel well screen or the bar grate, the trash rack maintenance is the same, which you need to go and remove all of the debris and trash from the trash rack. It might be after large storm events. This might be once a year. This is really depending on your site. And also make sure that it's present, that the trash rack is present and attached correctly. If you don't have the trash rack there, then the orifice plate will be clogging. And then if you have clogging with the orifice plate, of course, then you have the extra holding time. In this case, there was no protection between the orifice plate and the trash rack from the top. So the very top of the structure didn't have this plate where the shoes are located that you can see there. So what happened was there was large debris that blew into the space in between the trash rack and the orifice plate because there was not that protection there. So what we would recommend if we were going to maintain this site or inspect it is to say, we need to put a smaller grate here and definitely cover it right here so that we don't have this issue of this large, grassy vegetation blowing in and then blocking these holes right here. In some cases, you might need to do some repairs to the site. This is definitely for the maintenance side, or reattach any components that have come unattached. So here you can see the orifice plate, and here is the trash rack, and that needs to be reconnected in front of the orifice plate. So you might need to bring some new connectors and some sealant with you. Sometimes the connectors will not go back into the same spot that they were before. So you need to make sure that you have all the tools with you that you need in order to replace those correctly and firmly. Also, metal to concrete does not seal. So you need to have some sort of seal, a rubber gasket with you, or be able to bring some caulking to make sure that that seals properly. Here are two different styles of orifice plate. In the past, the way that the orifice plates were connected or were constructed were to have a exactly 40-hour drain time. So the civil engineers decided that they determined, based on the size of the extended detention basin, they determined exactly how many holes would be needed for that 40-hour drain time. Well, then because the holes were so small, they were getting clogged. So it wasn't actually a 40-hour drain time. So since that was what was happening, they determined, and Mile High Flood District was part of this, that instead of it being exactly 40 hours, it needs to be about 40 hours. So they decided to put one row of orifice plate holes, which is right here, instead of the 3 columns with multiple holes on this side. So if you're going out and inspecting a site and you see an orifice plate with 3 rows of holes, that's an older design. And then if you see an orifice plate with 1 row of holes, that's the newer design. And this could be something that you recommend to your owner, that if you go out there and you see that clogging is an issue, you might recommend, okay, let's make the orifice holes larger. Oh, I noticed that it's an older design. We can upgrade to a single row of holes in the orifice plate and then put on a bar grate instead of the well screen. Safety grate is the final component. As you can see here on the far left, that is a fully clogged safety grate. Nothing can get in there. You don't want things getting into your safety grate, but you need to make sure that it is clear of debris. You need to check for any structural damage and prevent trash and debris from clogging downstream pipes. So there it's partially removed in the middle picture, and then it's finally clear of all debris in the final picture. But they left all of the debris right next to this safety grate. So the next storm is just going to cover it again. So whenever you are removing, if you're going in there to do maintenance and you're removing this debris, you need to remove it completely. It needs to be off-site. You can't just clean something out, clean out your forebay and then dump it into your extended detention basin somewhere else. That's not solving the problem, and you're just creating more maintenance tasks later on. Here's an example of a site that lost their safety grate. And so they decided to DIY their project, which means do it yourself, and create their own chicken wire safety grate. So obviously this did not work, and that is not appropriate. Safety grates are fabricated pieces of equipment. They're not something that you can just make with things you have left over at your house. There's a reason for them. They need to be installed correctly. They need to be the correct size. So if you see this, please tell the owner that this is a failure of their outlet structure and that they need to replace the safety grate appropriately. Same thing for your outlet structure, still removing that sediment. You need to do this once a year. Any debris or vegetation that has accumulated in front of it, because you don't want debris and vegetation blocking the outlet structure. The outlet is where the water needs to leave. So you cannot be creating the situation where water can't get out, again, ponding issues. So the right picture here has riprap, which is those large rock, in front of the outlet structure. So riprap only needs to be where the inlet is, because the water, that fast flowing water, is coming in from the inlet. By the time the water reaches the outlet, it's no longer fast flowing, and it just needs, because it's having a controlled exit rate from the orifice plate. So we don't need energy dissipation at the outlet. The only place we need it is the inlet. So all of this had to be removed. As you can see here, it was creating a ton of ponding because the water cannot exit. So they removed all of the riprap, and then you can see this is the outlet structure after maintenance. This, they don't have a micro pool here. This is the initial surcharge volume area. So the area where water will pond first and exit last. So that's concrete underneath it, but you can see now the water has a clear path to exit the EDB because they removed that riprap. In this example, this outlet structure was installed too high. So the outlet structure should be at the very bottom, the lowest level of your EDB, so that water can flow in and flow out. If the outlet structure is too high, you'll just have this situation here where you just have constant ponded water. When you have ponded water, you have dying vegetation, you don't have the correct amount of pollutant removal, then you have standing water, and this will create a mosquito breeding area and cause a lot of problems for the residents around this space. So in this particular case, they needed to wait until, or to completely regrade this extended detention basin. Sometimes they'll just wait until it fills up with sediment completely so that the whole thing has failed and then redo it. But I would prefer, the preference would be to go ahead and fix it so that you're not having this problem of adding more pollutants to the water and having these issues with standing water and the problems that brings with it. Vegetation. When you have vegetation in your extended detention basin, the function of that is to stabilize the basin from erosion and also have this aesthetic benefit. You will need to establish your vegetation in some way. So having this temporary irrigation is one way to do that. This would be an especially beneficial way to do the native grasses that Frank was mentioning earlier. Native grasses in your extended detention basin, because you will need to water those, but then once established, you will no longer need to water it, potentially, hopefully. And so by having this temporary irrigation in place, then you can just remove it afterwards. What you need to do with your vegetation when you're checking it is just make sure there's healthy vegetation, make sure there's any necessary irrigation has been provided for. Avoid fertilizers. The reason why you want to, I would rather just say never use fertilizers, because again, with the stormwater control measures, we are trying to remove pollutants from the water. When you add in fertilizer to an extended detention basin, it will wash into the water and be very difficult to remove. And so you're adding pollutants to the water instead of removing them. So extended detention basins should not, or stormwater control measures in general, should not have any sort of fertilizers placed on them. And then when you mow these areas, you have to remove the lawn clippings. And I will show you why in our examples later on. Here is, additionally with vegetation, in addition to ensuring that you have healthy vegetation, you want to remove any of the woody vegetation that's growing up next to it. A lot of these areas that we're seeing extended detention basins have also become an area for people, like a green space. for people to use. And so I've been asked the question, is it okay to have trees in your extended detention basins? And it is okay. You just cannot have them next to any concrete, because that's when they start undermining them. That's when they start causing issues. So as long as the tree is not next to your inlet, your outlet, your trickle channel, and any concrete at all, you can still have them as that additive feature in your extended detention basin. In this case, people have left this woody vegetation, and now you're going to see failure of your trickle channel right here very soon. The embankments and overflow area of your extended detention basin, they need to be stable and sloped so that you prevent erosion and then safely convey water from very large storm events to the overflow area. So these extended detention basins, like I mentioned, it's 80% of storms. So for 20% of the time, these EDBs will overflow. And where will that overflow go? So you need to be sure to manage, where is it overflowing? Is it overflowing properly? Is the overflow area stabilized and not creating an issue downstream with more sediment or debris there? When you remove your debris, I was mentioning before, from the forebay, from the trickle channel, from the outlet structure, it needs to go to the landfill. You can't just use that material at a different project as fill material. It needs to go to the landfill. If you really need to use it, or if you really want to use it as fill material, then you need to get it tested first to ensure that there's no sort of toxins in there that could harm an adjacent watershed or that same watershed. So it's called the TCLP procedure, the toxicity characteristic leaching procedure, to determine if that fill material can be used elsewhere or if it has to go to the landfill. But usually it's best if it just goes to the landfill. It might need to be dewatered. If it's too wet, then it has to be dried out before it can go to the landfill, but otherwise it is an acceptable to landfill, and it's not considered hazardous waste. In this example is really just looking at, again, how do you maintain these sites? Is it easy for the proper maintenance to get to those areas? The maintenance roads, they have to have a stabilized access. That those roads need to be created with the type of vehicles that will be coming to do the maintenance for the proper loads. So when those are originally constructed, it's great to have that maintenance access, but if the maintenance access isn't have the correct loads, then you won't be able to get those trucks or the maintenance equipment to the site anyway. So that needs to be a part of your planning. And then ensure there's access to all of these different sites. So in this particular example, the trash rack is on the very front right here. And because this was a micro pool, potentially, they wanted to be able to get to this area to scrape off the trash rack. So they put these steps in so that they could have easier access to reaching that trash rack for maintenance. So this was a really great addition, something that you can look for if you're going out to maintain or inspect the site, and just make a recommendation on how you could have something installed that would make maintenance easier. Here is some proactive versus reactive maintenance and what it looks like when you don't have the proper components in place. So the picture on the right here, it's the same site, but on the right, they didn't have a trickle channel, they didn't have a forebay, and they didn't have a micro pool or a forebay. So there's a little bit of a trickle channel right here, as you can see. But because there was no forebay, the forebay is removing those items, that sediment, trash, and debris, before it enters the EDB. So because there was no forebay, all of that trash and debris went into the EDB, and then it clogged the outlet structure because there was no micro pool, and the micro pools help prevent clogging of the outlet structure. So this just became this mess. Because it became this mess, because those proper items were not installed, those proper components were not installed for the EDB. They had to completely redo the site. And now, of course, the vegetation looks beautiful and healthy. They have the forebay in place. They have the micro pool in place. And now their site looks and performs much better. Excessive ponding, we're using the same picture as the one before, and then an additional site that we'll be looking at during our examples. But this is because there's no micro pool, no defined initial surcharge volume. They weren't maintaining the site well enough, or it wasn't properly sized in the first place. And so you get this excessive ponding and the killing of vegetation, this very unfortunate looking area. You also need to make sure that the outlet structures are visible. So in this case, the outlet structure, we don't even really know how big it is because it hasn't been maintained properly, and that vegetation has started to take back that outlet structure. So you need to dig out this outlet structure so that you can see the trash rack at all times, clear away all that vegetation from this area right here, and then also cut back this area so you can see the full size of this outlet structure. Now, in an extended detention basin, the only components that you absolutely have to have are an inlet and an outlet. But what happens if you only have an inlet and outlet? So right here, here's the inlet, here's another inlet, and here's the outlet. So there's no forebay, there's no trickle channel, there's no micropool. So in this situation, oh, and also no defined initial surcharge volume. So what you get is a mess, essentially. There is just the sediment accumulates through the entire extended detention basin. You have the ponding issues, you have vegetation that is killed, all because those components were not put in. So if you go and inspect or maintain, or this is your site, then you just need to look at how it could be redone. Look at adding those additional components to have an actually effective EDB that's working properly. I'll pause here for questions before we go into the examples section. One of the questions that we had was the cost of the course to become certified for inspection and maintenance. And that course right now, the virtual course is $250 and the in-person course is $300. But we are looking to do, we actually just received a grant from the Colorado Water Conservation Board to translate all of our content into Spanish. And so we're really excited and grateful for that grant. We're also partnering with the Colorado Stormwater Council for that grant. And we will be looking to have additional resources for free seats, potentially for low income areas, and for having that Spanish translated certification being available for free. So we're looking at doing that, and then also putting our certifications online, because right now they are mostly in person and they're a full, either full 2 days or a day and a half. And so we want more people to be able to access these trainings. So we're looking to put them online. Hopefully we will have some certifications online next month. Okay. Are there any other questions? And Javier, I will be sending you that information by email. Thank you for the question. Okay, so let's look at some examples of extended detention basins. What might you see when you're out there, either on your own property or as you're driving around? Because I promise after this class, you'll be looking around and seeing EDBs everywhere and commenting on what they need to do to maintain those better. Or maybe that's just me. Okay, so site one is a site that I have pictures on 24 hours after a rain event. So 24 hours after a rain event, there should be water in an EDB because it's a 40-hour drain time. So there's water in this EDB. I'm not super concerned because I know of that holding time. But we need to look more carefully at this particular site because I'm seeing some issues even when there should be water in there. So already I'm noticing that this part needs to be maintained. If we were in person, I would definitely be calling on some people to tell me what they think needs to be maintained. So we need to remove, this is an inlet as it says here, so remove all of this vegetation. You would notice that there's no forebay here. So all of those materials are being sent directly into the bottom of the basin. You do see a trickle channel right here. Okay. So this is a different inlet. This is the same site, but it has multiple inlets. So the inlet right here is actually the one for way over here. Both of these pictures are from the inlet over here. So this particular inlet has two different pipes coming from separate areas that both feed into one inlet that go into this center area. So you can even see some ducks back there. They're right over here. Actually, there's some geese. They were really enjoying this ponded area. And then we start looking at the outlet. So as I'm looking at this ponded area, I'm thinking, this is too much water for the type of rain event that we had. So what is going on? Obviously, the water is not able to get out of this EDB. I wonder why that is. So I go closer and I start to see something blocking the outlet. So I look closer and what have they constructed? It is a little fence with barbed wire or with rebar and chicken wire. So the reason why this was probably put in place is because people were noticing, this owner was noticing that, oh my gosh, look, here's my trash rack. It's a well screen and it's clogging all the time. I wonder why that is. So since it's clogging all the time, I'm going to make a little fence around it so that it doesn't clog. As you can see, that did not fix the problem. What they should have done was to create, to possibly talk about upgrading their orifice plate so you can have larger holes so they could put a well screen on there. So that's just another side of how you could see that. And then here you can just see the extensive amount of ponding that's happening in this EDB and a closer look at this outlet structure. Okay, so let's see what happened 72 hours after the rain event. So if you all remember, 72 hours after a rain event, there should not be any water in the EDB because it is violating Colorado water law. So I go back and look at it and oh my gosh, this whole ponded area, this picture should look familiar because I use it a lot in the presentation. So look at how much vegetation has been killed by this huge ponded area. And you can see from one of the far inlets over here that you can already see how much damage has been done by the amount of ponded water. And look at that outlet structure. It is covered in grass and it is completely blocked and caked. And this is the reason why there's all this ponding happening. And it is this huge muddy mess, as you can see in the third slide. So this is not an attractive EDB. There's a lot of issues with it and it's causing more pollutants to enter the water than before. Okay, here's a different site that we're looking at here. And this site, so if you remember, a trickle channel, which is this, is supposed to convey flows from the inlet to the outlet. Where is the inlet? There's no inlet here. So there's no purpose for a trickle channel here at all. There's just no reason for one. So that was first thing that was noticed. They had an additional expense in this EDB for no reason. And then this, I'm starting to see some water here, but it was 24 hours after a rain event. So I was just checking it out, seeing I wasn't super concerned. And then I see there's water here. Okay, it's still okay. But then I see this inlet. This inlet has a ton of sediment in it, similar to the other site that we saw. There's two inlets close together. Both are full of sediment. The reason why they're full of sediment is because you're having ponding inside the pipe which should be slanted so that all of the water will flow through it and not stop inside the pipe. Because if you have water that's stopping inside a pipe, it's performing the same as your sedimentation basin should, the same function, where water is being held and then the pollutants and the sediment is dropping out. So all of that sediment is dropping out inside the pipe. It's extremely hard to clean inside a pipe. People are going to have to crawl in there and dig out all of that sediment. So I already know that there's an issue here. So here is the outlet structure. Here is the trickle channel that I showed you came from nowhere, because all of the inlets are right here. There's two inlets right here, which is the picture on the far right, and there's actually an inlet over here, which we'll see in a second. So here's another kind of viewpoint of what this EDB is doing. And it's confusing again, like why was this installed this way? This would be another part where you could recommend upgrading from this well screen to or from the aluminum grate to a well screen. Oh, no, to a aluminum, I'm blanking now, to the larger grate, the aluminum grate versus the well screen. And they do have a safety rack right here, which is good, but they still are having lots of issues, lots of maintenance. And we're also seeing a ton of grass right here, okay? So we'll be talking about that in a minute. 72 hours after, same site. Okay, now we see dead vegetation. We see a lot of sediment. So there is a lot of sediment that needs to be removed to maintain this site properly, and a lot of areas that can be improved. So from the arrows, this arrow is the other inlet. It is completely hidden by all of this vegetation. So that vegetation needs to be cut back, and a clear path from the inlet to the outlet needs to be there. And then you can see here, this vegetation needs to be removed. This vegetation needs to be removed, all of this sediment. And then once again, upgrading this well screen to a bar grate, because obviously they're not able to keep up with, it's not sized properly for the amount of water that is coming to that particular outlet structure. And so now I'd like to invite Frank back to talk about Northern Water sites and some examples from a conversion that they are working on towards native grasses.
Sure thing. So thank you very much, Jessica. This is a community in Fort Collins. It's called Pelican Ridge. It's an HOA that had cool season Kentucky bluegrass for its common area along the back of the property that was facing a private property, and they sought to transition the cool season bluegrass into something that was less water intensive and more sustainable, yielding additional ecosystem services while still retaining the high quality stormwater performance requirements that they had to in their oversight. And so this involved, I think it's 4¼ acres or so of a planned kill of the bluegrass using 2 applications of glyphosate. And what they intended to do was seed it with native seed in a seeding ratio that would provide really deep, intense coverage, but after initial irrigation, lead to less water intensity. And so what they did was perform those 2, and then they did aeration with multiple passes, and I believe 6 passes of aeration to provide for percolation. And then they did some upgrades to the irrigation system to repair some inadequate coverage and use the best available technology for rotors and heads and things of that nature. They also removed some of the tree material, a cottonwood and some others that were in the way. Warm season native grasses require full sun. And so for the most part, these were going to be okay with those junipers, as you can see, but the larger trees had to be removed. Both they were poor quality, and they would have also impeded the growth of these native grasses. So the seeding rate here is pretty high. I want to say 4 pounds per acre, and it's a mix of buffalo grass and blue grama. I believe it's 80-20. And the seeding was done with multiple passes using a drill seeder at a very shallow depth, something around 1/4 inch or so. And then there was a hydro mulch with a tackifier installed or applied on top of it, which helps ensure that those seeds stay where they're planted, provides a nice germination bed to get the water to stay in and allow for proper propagation. And then also takes care of concerns around if there was a large precipitation event where those seeds would wash off, or if there were activities back there. You want to make sure that good coverage occurs. Then there's very careful management of the irrigation to get to a quality establishment. And as you can see, this project, which was done this summer and just concluded, had really nice coverage. This is good plant health, and it is able to replace the cool season bluegrass in its stormwater performance while adding these other benefits to the community. This will only grow to a certain height. Currently, it's at a pretty low height to where it mimics a bluegrass appearance, but it can be left to go to its native height, which is preferred, because then you get the best plant health and you have a little more ecosystem benefits, as well as reducing your maintenance costs. So this can be let to grow to around 12 to 18 inches high, or it can be mowed down too. It does require a regular amount of weeding. The project proponent, his name is Don, did a lot of that weeding by hand, and you can do that carefully, but you want to not disturb these sensitive seed beds during germination. You can also do chemical management, but you have to use specific herbicides to address the broadleaf weeds that get into these areas. But over time, this is a really functional way to maintain stormwater performance. You can see the trickle channel there, which was properly maintained. And as that water will sheet off going to the south toward a body of water, it enters into the native grass that is maintained by a different owner. So here's, in our minds, a really successful example of a transition meeting the requirement, adding benefits to the landowners, and also is quite drought resilient. So if you'd like to see this, you can get to the neighborhood. It takes a little bit of back roads, and you can see it actually from Highway 287 as you're heading into South Fort Collins on the right. It's going east. So that's my example, and we hope to propagate more of these projects in the future so that we can share with folks how they can save water in their stormwater basins.
Thank you so much, Frank. This is beautiful grasses, and if you are interested in learning more, please reach out to Frank. They will be, he's the best person to speak to about this potential transition and this great work moving forward. So I want to show everyone that we have an inspection and maintenance field guide. It is available online via that blue link right there, but we also have it for print. So this is what everyone receives when they go through our inspection and maintenance class. And it has sections on the different things that we discussed, but the whole entire front section is on extended detention basins. And it goes through the points that I outlined here today, like how to identify the components, what they should look like, what you should be looking for to remove at each section. So this is a really valuable piece of material and a guide that we have. We will be translating this into Spanish as a part of our grant, but for right now, we do have all of the English versions already printed out. And the online version is in English as well, but again, that will be changing later on next year. If you would like to receive a printed copy, just set up an email, email me and set up an appointment to stop by the Stormwater Centers, pick one up. Here is my information if you would like to email me, if you have questions, if you're interested in learning more about our certifications. There is just really a couple of additional sections. It is a 1.5-day long training for our inspection and maintenance class. And so we go into more depth about, everything that we covered here today and more, but you're on the right road. You're starting that track of getting certified in inspection and maintenance. So if you're interested, please reach out to me about that. And we have all of those resources that I listed up initially in the first slides at the Colorado Stormwater Center, and there is the website. So I'd like to thank you so much for joining us today. I would like to be available for questions, but just want to thank Northern Water and CDPHE once again for hosting us and allowing this opportunity to share these stormwater control measures, the how to inspect and maintain extended detention basins for free, so that more people could access this material and know how to protect them moving forward. So I will be here for questions. Again, you can unmute or put them in the chat. Thank you, Edward. It was great to have you here, and I look forward to answering any that you might have. Thank you. Thank you, Javier. Thank you for attending. Oh, and before everyone leaves, we will be sending out this recording and a survey after this class, maybe by early next week. To please send me your feedback. We just want to improve our classes moving forward. And then if you missed parts of the recording, or if you have other folks that would be interested in watching, those will be available on the Northern Water and Colorado Stormwater Center YouTube pages. Thank you, Joe.
I'd just like to say thank you, Jessica. Really appreciate the time you took to put these together and working with you on this very important topic. It's clear that as you look around the communities, you see a lot of these do need this maintenance, and I'm hoping that through this education, a lot more of these folks will get a chance to improve them and let them perform as they should.
Thank you, Frank. It's been a great partnership. We appreciate the support of Northern Water very much. Does anyone else have any questions? Otherwise, I will let you continue with your day and look forward to the videos later. But I'll allow for another couple of minutes in case anyone has any questions. And lastly, but not least, I would like to also thank our wonderful interpreters. Thank you to Elizabeth and Daya. I'll let everyone go. Thank you very much.